Everyone, I'm Wan Li. I'm going to explain a little more about qualitative variable in regression analysis. Last time we studied the dummy variable. Dummy variable takes 1 or 0 for two classified classes. But many qualitative variable classified more than 3 classes. So how to use dummy variable in this case and how to interpret the coefficient with example. All right, so a little difficult than only one dummy variable case. Example, two qualitative explanatory variables case. The following is data obtained from 12 individuals to perform a regression analysis on Y. Income is Y income. There are 12 individuals using 3 explanatory variables: years of work X, and gender GEN, like this, and education level EDU is 1, 2, 3, 3 classes. EDU takes 1 when high school graduate. EDU takes 2 when college graduate. EDU 3 graduate, okay, graduate school. Then if you use this kind of a model, beta 0 plus beta 1 gender plus beta 2 EDU plus beta 3 X plus epsilon, you cannot interpret the coefficient of beta 2 because 1 unit increase of EDU, 1 unit increase EDU, then the increase or decrease beta 2 much of income, right? So it is meaningless. 1 unit increase of EDU is not meaningless. We want to compare, we want to know high school graduate, college graduate, the difference of income, college and graduate difference of income, and what? College and graduate, high school and college difference. We want to know that kind of a thing. So we have to define 2 dummy variables, E1 and E2, like this. E1 is high school 1, others 0. E2, college 1, others 0. So 2 dummy variables defined, then you have to input this kind of values, okay, E1, E2, in your computer. E1, E2 becomes 1, 0. This EDU becomes E01 as E1, E2. College 01, graduate 00. High school E1 value 1, E2 value 0. College E1 0, E2 1. Graduate 0, 0. Something like this. Okay? So you have to change your model to this kind of a model. Beta 0 plus beta 1 gender, beta 2 E1 plus beta 3 E2 plus beta 4 X plus epsilon is your model. Okay? And you import this data, E1, E2, this data into your computer, and you get result like this. Intercept 192.56, p-value is 000, and the gender 13.32, p-value 0.023, and E1 minus 38.40, p-value 000, okay? Minus 15.62, p-value 0.064, and for X 6.56, p-value 0.007. R-square, you got very high R-square value, 94.5%. You get it? Everything all right? Now, how to interpret this one and this one? There is no problem of this coefficient, 13.32. What is that? Compared to male, female increase takes income 13.32, right? Female more income, this much, 13.32. And this one unit of increase, one more year of work, okay, then he or she takes income 6.59 more, okay? Now, so the problem is beta 2 hat, beta 3 hat. Let's see here, same result here, and the model is like this. Let's see. Let's interpret the estimated coefficient. The coefficient of x, this one, which is 6.59, indicates that for each additional year of work experience, income increases by 6.59. No problem. The coefficient for being female compared to male is 13.32. 13.32, meaning females earn 13.32 unit more than males, right? Now, this one, compared to master's degree holder, high school graduate on 38.40 less, because minus sign less. So this is base. Master's degree holders, it will be the base. See again here, graduate 00. So high school 10. So the coefficient of beta 2 means compared to graduate score, master's degree holder, high school graduate on 38.4 less, minus. This one is what? Compared to master's degree holder, graduate score, college graduate on 15.62 less, minus sign. Then we compare high school versus graduate, college versus graduate. Then what is the value of coefficient high school versus graduate? High school versus graduate, college graduate on more than this much, more than high school graduate. What is it? This one is beta 3 minus beta 2. Beta 3 is minus 15.62 minus 38.4 minus plus. So that is 22.78. College graduate on 22.78 more than high school graduate. So we compare these three groups: high school, college, high school graduate, and college graduate. What is this table? This is some theoretical thing. Okay, this is your model, right? Expectation of y is just this part here. Then high school and female, beta 0, this one is beta 1, value of beta 1 is 0, right? Beta 2, E1, E1, value of E1 is 0, high school. So nothing here, plus beta 4 year, X. High school female is beta 0, beta 1, plus beta 2, plus beta 3 year. So the difference is beta 1. Female has beta 1 more than male for high school graduate. College, same thing. Beta 1 is female more than male, beta 1. So you can see the coefficient of beta 1 in here, but we concentrate on beta 2 and beta 3. Beta 2 is what? The difference between these two groups, beta 2 more. High school has beta 2 more than graduate, right? And female also beta 2 more here. Here, there is no beta 2. So beta 2 means compared to graduate, high school on beta 2 more income, right? And the beta 3, compare these two group, then beta 3 more in college. than graduate. Here, female, also beta 3 more here. So beta 3 means compared to graduate, beta 3 more income, college graduate. So beta 3 minus beta 2 means college graduate, uh, high school more 22.78. In other words, beta 3 minus beta 2 more than high school graduate. So we may compare between groups, high college, high graduate, college graduate. That's we wanna try to know from this qualitative explanatory variables. You understand that? A little complicated? All right, that's it. That's it here. And another thing is when y is dummy variable, 1, 0, success, pass, 0, failure. In this case, it is a more complicated thing because y equal to beta 0 plus beta 1 x plus epsilon, we have assumption about error terms. Then normal distribution, the assumption is, then y is cannot be normal distribution, right? It only takes two values, 1 or 0. So it will be complicated and you cannot apply the usual normal process. This problem says logistic regression analysis. So it is another topic, and I think it is graduate level statistics. But I'm going to explain logistic regression later, okay, in appendix, like appendix. Okay, thank you. Bye.